For those of you watching the second part of this video, welcome back. For the first part of this video, I'm going to go over numbers 1, 3, and 5, so the odd numbered problems in station 1, where we're simplifying radicals. And I'm going to go through each example very slowly, so feel free to fast forward at any point. I'm not going to show you just with the largest perfect square. I'm going to show you at least 2 ways to simplify each of these radical numbers. So let's start. You have your reference sheet, but for us to follow along together in this video, I'm going to list out the first 10 perfect square numbers. So if I wanted to just glance at my list of perfect square numbers and think about which of these factors would go into 200, which of these would be factors of 200, I might notice that 4 would work here, 25 would work here, and 100 would work here. Okay, so let's use 2 different values. So I'll simplify using 25, and then I'll show you using 100. So again, we're not changing the value of 200, we're just rewriting it a different way. So 2 numbers that multiply out to 200 using this perfect square of 25 is 25 times 8. Okay, so now this will simplify to radical 25 times radical 8, which is 5 radical 8. But again, we can't stop here because you have to ask yourself, can I break square root of 8 down any further? So think about the factors of 8, numbers that you multiply to get 8. And if you'll notice, 4 is one of those factors. Since 4 is a perfect square, that means that we are not done just yet. Okay, so continuing on the side over here, we now have 5, and we're just rewriting 8 using 2 factors. We're going to use 4 times 2. Okay, so now we have 5 radical 4 radical 2. So I've just gone ahead and I've split this to have their own square root symbol. So now we have the 5 times, so when the number in front of the square root symbol, the number in front of the radical, if there's no symbol there and they're right next to each other, that automatically means multiplication. So that's why I'm putting that dot for multiplication. So the square root of 4 simplifies to 2, and the square root of 2 is irrational. We can't break that down anymore, so we're going to leave it alone. So now we can multiply the 5 and the 2 to get 10 radical 2. And this is our final answer. So I'm going to highlight this in yellow, and I'm going to leave this here. Might be a little bit crammed, but I'm going to do my best to show you another way to simplify this using the largest square, the largest perfect square factor of 200, which is 100. Okay, so let's use a different color here. Let's use green. Right, so we're still simplifying radical 200. And we can also write 200 as the product of 100 times 2. So now we can simplify this as radical 100 times radical 2, which is 10 times the square root of 2. So again, we've ended up with the same answer. We've just taken a different route. Okay, this next example for number 3, I'll list out the factors for those of you that like to go that route. So let's list out the factors of 72. So numbers that we multiply, let's try to make that straighter, multiply together to get 72. So take a moment to list them out yourself, pause the video, and when you unpause it, I will have all the factors listed out for you. Okay, so 72 has quite a few factors, and there are a few that are perfect squares. So let's go through our list. So we have 4, which is a perfect square number, 36 is a perfect square number, and 9 is a perfect square number. All right, so if you start by simplifying using the largest perfect square factor, which is 36, that'll save you less steps. Okay, so let's rewrite the square root of 72 as the product of its largest perfect square factor, which is 36, and 2. So we can now simplify this to radical 36 times radical 2. Ooh, that looks like a minus sign. All right, the square root of 36 is 6, and we are multiplying that by radical 2. So we have 6 radical 2 in simplest form for the square root of 72, right? So that would be how you do it, listing the table. It might take a minute or two longer, but this really is the best strategy to go with until you become more comfortable in identifying the largest perfect square factor. So we're gonna do number 5 the same exact way. We're gonna list the factors of 52. I don't wanna erase that example that I have up here in case you're still copying, so you can keep the video paused and not have to rewind. So I'm just gonna rewrite 5 over here. So number 5, we're simplifying radical 52. So again, let's list out the factors and unpause the video. So you should always try to do it yourself. Don't just wait for the answer. I'm here to help. But you should be trying to list them out on your own first. So pause the video, try it yourself, and then unpause it for the list of the factors. Okay, so 52 does have fewer factors, and it only has one factor that's a perfect square number. So we're going to rewrite the square root of 52 as the product of 4 and 13. So we have radical 4 times 13. And again, split this into radical 4 times radical 13. The square root of 4 is 2. 13 is prime. We can't break it down anymore. And we have our final answer in simplest radical form. We'll do an example together in which we're applying the Pythagorean theorem and then using what we just learned about simplifying radicals to write our answer in simplest radical form. So let's read carefully. A right triangle has one leg measuring 20 feet. It has a hypotenuse that is 3 times the length of the other leg. What is the measure of the hypotenuse in simplest radical form? Okay, so we're going to read it once more after we draw out a right triangle. You should always draw out a diagram and label it. Okay, so here we have our right triangle. So let's read it once more, and as we read through it, we're going to start labeling the sides. A right triangle has one leg measuring 20 feet. So we have both our legs here, A and B. So let's label one of them to be 20 feet. It also has a hypotenuse that is 3 times the length of the other leg. So since the other leg is B, and that's the unknown side, 3 times that leg would be 3B. So this is what is represented by our for our hypotenuse. It kind of looks like a 6. It's not 36. That's a 3 times B. Right? So what is the measure of the hypotenuse in simplest radical form? So we're going to start by writing out the formula for the Pythagorean theorem. A squared plus b squared equals c squared, and we're going to substitute our values now. So for A, that's the first leg, which is represented by 20 feet. So we have 20 squared plus the unknown side for the second leg is b. So that's represented by b squared. And our hypotenuse is represented by 3 times the other leg. So 3 times b, right? So 3b squared. Notice I put parentheses around the variable before I substituted. And that's because we have 2 values here that we're going to square. We're going to square the 3 and we're going to square the b, right? So anytime you're substituting a value where it's multiplication of 2 different values, always use parentheses, right? So for 20 squared, we have 400 plus b squared is equal to, so now we have 3 squared, which is 9, and b squared, which is b squared. So notice we have one variable to solve for. We have to solve for b somehow, right? So the coefficient for the b on the left-hand side is 1b squared. We're going to go on ahead and subtract 1b squared on both sides of the equal to bring those variables together. So we're left with 400 on the left is equal to 9 minus 1, 8b squared, right? Few more steps until we get b. We're going to use the inverse of multiplication and divide by 8 on both sides. So we're going to have b squared is equal to 50. Okay, so now if b squared is 50, if we take the square root of both sides, right, the square root of b squared, the square root of 50, we get b is equal to the square root of 50. So our final answer is to be in simplest radical form, not putting it into the calculator. So we're gonna continue the work over here. You definitely have enough space for this example on your handout. It's just getting a little crammed on my video here. So radical 50 can be rewritten as 25 times 2. The square root of 25 times the square root of 2 is equal to b. So 5 times radical 2 is in simplest form now. And this would be our final answer, 5 square root of 2, 5 times the square root of 2. Okay, so we have the length of the missing side. So b is equal to 5 radical 2. The question, however, is asking, what is the measure of the hypotenuse? And we know that our hypotenuse is 3 times the value of the missing leg that we just solved for. So 3 times the value of our missing leg. Okay, so one thing to be mindful of, we're not applying distributive property here. In order to apply the distributive property, we have to have more than one term. So we would either have to have a plus sign or a minus sign between 5 and square root of 2. So since this is all multiplication, we're simply going to multiply 3 times 5. And 3 times 5 is 15. So the measure of the hypotenuse in simplest radical form is 15 radical 2. Okay, so now it's your turn to try some of these word problems on your own. So a few things to be mindful of. Use your perfect square sheet. Use all the tools that are given to you to help you solve the problems. List all the factors and find the largest perfect square factor so you can make a table and factor them out and look at your values that way, comparing it to your perfect square sheet. Make sure that you are in simplest radical form to the point where you can no longer break down that square root number. So prime numbers such as the square root of 2, the square root of 3, the square root of 5, the square root of 7, and so on. Or not even prime numbers. You can have numbers that don't have factors that are perfect squares, such as 10 or 15, right? So reference your square root sheet if you are not sure what the factors of 10 and 15 would be, for example. You can use your calculator to divide them out into 10 and see if any of them would nicely divide that number and give you another whole number. And lastly, show all your steps for the Pythagorean theorem. Don't get lazy. Actually write out the formula. A squared plus b squared equals c squared, or leg squared plus leg squared equals our hypotenuse squared. Show every step that you're changing so that you don't make any errors, any silly mistakes. Show all of your thinking. All right, good luck. Have a great day.